All right, section 7.4, part 2. Sometimes, so we've talked about solving polynomials in factored form using the zero product property, meaning if you multiply two factors and get 0, that tells you one of the two factors must be 0. Okay. So sometimes you end up with where the two factors are the same. For example, an x minus 2 and an x minus 2 is the factored form of x squared minus 4x plus 4. Okay, these are the same. This is the factored form of it. And when I set each one of these equal to 0, if I set x minus 2 equals 0 or x minus 2 equals 0, I would add 2 to both sides, x equals 2. Well, this one's going to give me the same thing, or x equals 2. So the solution of 2 happens twice. This is what we call a repeated root. If 2 or more of the roots end up being the same number. 2 or more roots are the same number. We just call it a repeated root. It could repeat once, it could repeat, well, it can't repeat once. Could repeat twice, could repeat 3 times or 4 times. If it only happens once, it's not repeated, it only happened once. So if you have 2 or more roots that are the same number, we call them repeated roots. Just talk about that vocabulary a little bit. All right, so here we want to solve each of these equations. This first one, we have 2x plus 7 equals 2x minus 1. It's in factored form. My two factors are 2x plus 7 and 2x minus 1. So I'm going to set each of these, 2x plus 7 equals 0, or 2x minus 7 equals 0. Now these require a little more work to solve. So I need to solve this guy right here. Well, to get the x by itself, the first thing I'm going to have to do is subtract 7 from both sides. So 2x equals negative 7, and then I have to divide by the 2. So x equals negative 7 halves. Now we'd want to simplify that fraction if we can. That fraction doesn't simplify any farther, so we'll just leave it just like that. So there's one of the solutions. Now we need to solve this guy. Same similar process, but instead of subtracting 7, I need to add 7 to both sides. So 2x equals 7, divide by the 2. So x equals positive 7 halves. So there's my or. So my solution, if we put in the solution set, we could do it as the plus or minus 7 halves, because we have positive 7 halves and we have negative 7 halves. Okay. Next one. Okay, this one looks a bit weird. Okay, it's just because we have it written shortcut. Really what this means is I'm taking x minus 1 to the second power. I'm taking this x minus 1 times itself. So I'm going to write that out. I'd have x minus 1 times x minus 1 equals 0. So then I can identify, there's my two factors, 1, 2. So set each one equal to 0. X minus 1 equals 0, or x minus 1 equals 0. Let's add 1 to each side of this little equation over here. So x equals 1. Do the same thing over here. X equals 1. So here we have 1. X equals 1 is my repeated root. It's happening twice. So we have a repeated one. It has a repeated root, so a lot of times we will just write that as a solution. It has a repeated root, x equals 1. That tells us it happens more than once. Okay, now next, tricky. This one has got 3 factors. An x plus 1 times an x minus 3 times an x minus 2 equals 0. Well, the same thing holds from our zero product property over here. If I'm multiplying 3 things and getting 0, it still means one of them has to be 0. So we're going to do this the same way, except now we're going to set 3 equations equal to 0. X plus 1 has to equal 0, or x minus 3 has to equal 0, or x minus 2 has to equal 0. And then now I need to solve each of these 3 little equations. So here, x plus 1, I'd have to subtract 1 from both sides. X equals 0 minus 1 is negative 1. Or if x minus 3 equals 0, I'd have to add 3 to both sides. x equals 0 plus 3 is 3. Or, now here x minus 2 equals 0, so I have to add 2 to both sides, x equals 2. So this equation actually has 3 solutions. And if we write that in a solution set, least to greatest, -1, 2, and then 3. This one has 3 possible solutions. Okay. All right, before we go on to the your turn for this section, I want to talk about what these equations look like and what the visual is. So what I'm going to do is I'm going to graph a couple of these. So I'm going to take this guy and I'm going to graph it. So I'm going to open Desmos. Let me get Desmos open. Okay, and I'm going to, let me get rid of all that stuff, and I'm going to graph this guy right here, parenthesis. I'm going to graph it as y equals, parenthesis, x minus 1 squared. Oh, my squared needs to be out here, squared. There we go, x minus 1 squared. So what this does is if we look at it, if we want to look where does this guy equal 0, if we trace along here, it equals 0 right there. It equals 0 when x is 1. And isn't that what we got? It equals 0 when x equals 1. Okay. So then what about this next one? What about this one? Let's go ahead and let's graph that one. I'm going to type it in as y equals x plus 1, x minus 3, and then x minus 2. Oh, look at this crazy guy. It's doing all kinds of crazy stuff over here. But if we notice, if we want to know where it equals 0, look, it equals 0 at -1, at 2, and at 3. And isn't that what we got for the 2 solutions? When x equals -1, 2, and 3, it's 0. Okay, so we can see where those on that graph of these functions, those zeros, those roots occur where it crosses the x-axis. Okay, so just to get us a visual on kind of what it looks like. We're not going to be doing much with graphing them quite yet, but just wanted to kind of see what they look like. Okay, so here, your next your turn to problems, page 381, 10 through 24 even. Good luck.